Yeah.
Yes,
Something
sir.
related to what?
So we did destructive
Not,
interference, constructive interference, and all that stuff. So,
no, not in that thing. So that is wave optics. In electric potential, what did we do?
so electric potential. It's
Electric
a
potential, electric potential. Yeah,
which
because we are.
I which one second. Just oh no, man, nothing, sir. It's just, I have a test also today, sir, at 8 p.m. Like this class ends at 8 p.m., right, sir?
Yeah, so 8 p.m. if we minus 2.5, so how much is that? This is 5 point. Oh, we have to add it. Yeah, at 8 p.m. Yeah, this class. So
Okay, sir.
your 8 p.m. Yeah, your 8 p.m. is mine 10:30, right? So yeah, this class will end.
Yes, sir. I have a test at 10:30 for you.
Oh yeah, so let me just recall what did we do in this.
Yes, sir.
So we calculated electric potential, right? We calculated electric potential that was related with the work done in bringing a charge from infinity to a fixed point. This was the electric potential, right? And then we calculated the electric potential of a single point charge. So that was kq by r. Then we calculated multiple charges. So that was this thing. And then we calculated the electric potential of a dipole, right? Single charge, multiple charge, and then dipole. So what was the electric potential of dipole? Remember? That was kp cos theta by r square. Right. This was the potential of electric dipole that we calculated. Right.
Yes, sir.
Okay. So now, if you remember that in electric charge and fields we studied about, so we have the dipole, right? And uh, we are calculating the electric potential at this P point, right? And this is making an angle theta with this center. So this was A, this was A, this was theta. This distance was r. Now there are two regions of this dipole, right? So if you remember, there were two regions. One was this, right? This was called the axial point, and then we had this another region which was this. So that was the equatorial point, right? So if I choose my P to be here, if I choose my P to be here at axial point, so what would be this theta? What would be this theta then?
So the theta will be equal to minus q.
Theta, I'm asking about theta is the angle, right?
Yes, sir.
Theta
Yes,
is,
sir.
so how much would be the angle if I choose my P to be there at axial point?
1 second, sir. My grandma is talking. Can you just repeat what you said, sir? She's just speaking to someone different, sir.
Yeah. So I am saying that this is your theta, right?
Hmm?
this theta you have chosen this point. Now what you do is that you can choose this point to be here. So this is the axial point. Then at this axial point, what would be the theta? What is the theta? What is this theta? So how we are measuring the angle? How we are measuring the angle? Okay, so there is a lot of background.
So P goes theta by
Yeah,
R square.
yes.
No, sorry, I'm thinking.
Okay. Yeah, okay. So how we are measuring this angle? If we measure the angle by two arms, right? So this arm and this arm. So between these arms, we make the angle, right? So how we are measuring this angle? We have this arm, right? And then this arm. So this arm is at B. This arm is still there. And to have this P point in here, so this arm would be in here, right? So I have one
Yes.
arm here and the other arm here. So what is the angle? Did you understand the question?
No, sir. Can you just repeat it one more time?
So yeah. So how am I measuring the angle? I have this P point, right? This arm is there. So whatever this arm is making the angle, that is my theta,
Yes,
right?
sir.
Now if I choose this P point to here, so my arm is this. My other arm is this. Right? This is always the same. So now what is the angle if I choose this P point?
So the angle would still be the same, right? Because that's just
Okay,
because
I have
the
this angle.
yes, sir.
And then I have this thing and I take this arm to be here. Now what is the angle?
So the
What are the
angle will be 0.
zeros? That is the angle, right? That is what I'm asking. So if I take this P point to be here, then what is this theta? This theta would be zero. Clear?
Yes, sir. Yes, sir. I wasn't understanding the question. I thought you were talking about the lower angle will be you're extending the lower angle, and I thought that it would still be the same, right? I was just thinking that how can it be different? That's why I was getting confused.
Yeah. So yeah. I was saying that this P point, now you are taking this P point to be here, right? So your arm is here, but you are taking this P point to here. So now your arm is here. So both the arms are in the same direction. So theta would be 0. So at axial point, theta is 0. So P axial would be how much? Kp cos 0 by r square. So this is Kp by r square. Clear? This is the potential of the dipole at axial point. Is this clear?
Yes, sir.
Now, second thing is at equatorial point. Now you tell me what would be the angle at equatorial point. Now, you tell me what would be the angle at equatorial point if I choose this point, the equatorial. What is the angle? What is the theta?
90-degree.
90, absolutely correct. Good. So this part you understood very quickly, right? Because now you are taking this arm to be here. So this would be 90.
Yes, sir.
So this theta is 90 degree. So P equatorial would be how much? That is Kp cos 90 by r square. So how much is this thing? How much is cos 90? Yes.
Cos 90, so it will be, hmm, let's say,
Cos 0 is 1, right?
yes,
Cos,
so cos 0 is 1.
cos 90
Cos 90 will then be 0.
is 0, right? So cos 90 is 0. So cos 90 is 0. So this whole thing multiplied with 0, that becomes 0. So at equatorial point, potential is 0. So these are the two findings, right? Whatever we got, so these are the two findings. Please note it down. And yeah, so from here, we in the last class we stopped at here. So now please down and start revising. Okay, start revising. Otherwise, all the things you will forget.
Yes, sir, I'm done.
Yeah, good. So now, yeah. Now let us understand. So I will ask you this question again, and let's see if you remember it or not. So, okay, we have a charge, right, that is placed in some electric. So we have this electric field, and some charge is placed, right? Some charge is placed in this electric field, positive charge. So what would be the force that this charge would experience? What would be the force? Yes, what would
Yes,
be the
sir.
force? So this charge is placed in this inside this uniform electric field.
Hmm.
So what would be the force this charge would experience?
So positive.
Yeah. Yeah, positive, this is the positive charge. So what would be the force?
Sir, it will experience negative force because the positive is attracting negative. So, what kind of force it will experience?
Yeah, so let's say you have this electric field, and in this electric field you put some charge. So
Okay,
then
sir.
what would be the force? What would be the force on this charge?
Force experienced
Again, you
electromagnetic
got
force.
that is what I was telling. Please revise, please revise. Otherwise, guys, how many times see I these things? Whatever time, whatever many times I do this thing, if you won't revise, then you will forget, right? So these are very crucial things. So this will experience the force in this direction, and that is QE, right? So if this charge is placed in the electric field, so this will experience a force in the same direction as this electric field. That is QE. So that is the electrostatic curve. Now, do you remember this?
Yes, sir.
Okay, so we have this charge in this electric field, and now we want to displace this thing from, let's say, A point to B point, right? We want to displace. So then we have to put external force, right? We have to put some external force to move this. Okay, so we have to put some external force, and that external force would be in the opposite direction. That external force would be in opposite direction, right? If we want to move this thing from here to here. Clear?
Yes, sir.
And this F external would be how much? That would be minus of electric, right? So then this F external would be how much? We know that this is QE, so that would be minus Q. Clear? So
Yes, sir.
this now what would be the work done in the external electric field? So work done in moving a charge from let's say point initial point final this would be how much this would be uh, work done in a charge from initial point to final point, and work done is related by the force, right? So that would be F external, right? And whatever distance you are right, so let's say delta R distance, right? And you know that what is this F external? F external is minus Q, right? And delta R is what? This is R final minus R initial. That is the displacement, right? You are applying some external force and you are displacing this charge from here to here, right? This is initial point, this is final point. So that would be the work done. Is this thing clear?
Yes, sir.
Okay. And I can write this thing as, yes, I can write this thing as minus Q and dot delta. So now what is happening? So what will happen is that we already know that how this work done is related with this potential, right? So we already know that this work done is related with the potential. Okay, so do that. We'll do that later. But, yeah. So now this electric field, now this electric field can be of two types. And how many types it could be? It could be how many types there how many types of electric field there how many types of electric field would be there?
How many types of electric fields are positive and negative?
Electric field, positive electric.
I mean, sir, yes, sir,
Charges,
positive.
charges, charges are positive and negative, right? Electric field doesn't have the polarity. They have directions, right? They have
So yeah,
direction, but
polar
they
and
can't
non-polar,
write
right?
polar and non-polar are charges, right? Okay, so electric field could be uniform, which is constant, and electric field could be variable or variable, right? So, and what is the variable electric field? Let's say electric field is x square I hat plus y square g hat plus x square y square z square. So this kind of electric. This is depending upon the variables. So this is a variable electric field. Constant electric field is simply 2i plus ej plus 4k. So this electric field is not depending upon any variable. So this is a uniform one, this is a variable one. So again, due to these two different types, the work done would be different, right? So work done for uniform electric. So that would be simply this is minus QE dot R final minus R. So that would be the work done. Clear? Is this
Yes, sir.
and if we have a variable field, then what did we use in the case of the potential? Do you remember what we did? What did we do? So we used integration, right?
Yes, sir.
This would be minus q e dot dr from r initial r final, right? So this would be the what? Is it clear?
Yes, sir.
Okay, so we'll do one question based on this. So we'll do one question and then it will be very clear. Right. So please note down this part and then we'll do one question. Then it will
Yes,
be
sir.
very clear. Then it will be clear. Yeah, whenever you need me to scroll down, please.
Yes, sir, done.
Then please, yeah, whenever you have noted, please tell.
No, yes, sir, yes, sir. 1 second, sir. Yes, sir, noted.
Just do this question and then we. So what is work done in bringing or moving, right? A charge, let's say -2 microcoulomb from point A, which is 1 to 5, point which is uh, right in the presence of an electric field, which is I plus 2J minus. This is the question. So what are the things which are given? We are given a charge which is -2 microcoulomb. So this microcoulomb is not the SI unit, which means that we have to change it. Micro is how much?
Sir,
Yes.
10 raised to minus.
Yeah, 10 is to minus. How much? Micro.
Micro return raised to minus 8, sir.
Minus? Yes, minus 6. This is micro,
Yes,
right?
sir.
This is micro. And these are standard, right? So this is volt meter or yeah, so yeah, this is volt per meter or we can write it as Newton per meter, whatever units we can write. Okay, so this electric field is Ti plus 2J minus 3K hat. And then this is the point. So what is RA vector? What would be the position vector of A? How much would be the position vector? So that would be IK hat plus 2J hat plus 5K hat. That would be the position vector, right? These are components, X, Y, Z components. So this would be the position vector. Clear? What is RB vector? What is the RB vector? Arsenal.
Sir, 3i plus 4j plus 2k.
Yeah. So this is TI plus 4J absolutely correct. So we know all the things, right? We have these information and we have to calculate work done in moving a charge from A point to B point. So this we already know. This is a uniform button. So we will use this, right? RP minus RP. So this would be the work done, right?
Yes, sir.
So Q we know that is minus of 2 into 10 to the power minus 6. E is how much? This is 3i plus 2j minus 3k. And let us calculate RB minus RA. So RB minus RA would be 2i j minus 3k. So RB minus RA dot I plus 2j minus 3k. So what would be this minus minus is positive, so 2 into 10 to the power minus 6. And what would be the dot product of these vectors? What would be the dot product?
So it will be 6i plus 4j minus plus negative 9k.
Dot product is a scalar product. Dot product is a
Yes,
scalar product. So there would not be any vectors, right? So we were
yes, sir.
saying currently only these components would be there, right? So minus 3, that would be. So only these parts would be there, not the IGK, right? Because
Yes,
if
sir.
we have this IGK, that would be the vector product, right? But the dot product is not a vector. Yeah. Okay, so 9, 13, and 6, 19. 19 into 2, 38. Into 10 to the power minus 6, which is 3.8 into 10 to the power minus 5 joules. Because everything we are writing in SI. So this would be the work done. Is it clear?
Yes,
So
sir.
this is the work done in the presence of a uniform electron. So you please note it down, and then we will do other questions. Yeah, whenever you have noted.
Yes, sir. Done.
Okay. So now let us remember this thing. So this is an important result to understand, right? The work done is also related. So we already know. what do we know? That but this is also related with the potential difference, right? So work done is related with, let's say, if we want to calculate work done from initial point to final point, this is Q V final minus V initial. So that is how this work done is related to the potential, right? This is a very important result and always remember this. This comes in very handy. So let's say WAB, that would be QVB minus, right? So always remember this. And from this, we get idea of potential. So if, yeah, okay, so now using this quantity, let us understand about the potential difference, right? So what is the potential difference? What is the potential difference? So it is the work done in who is joining now? Yes, Assalamu alaikum, Peer. So 50 minutes late.
Walaikum assalam, sir.
Yeah, so completed quite a lot. Okay, yeah, so this is the new topic that we are doing, right? So we are understanding about potential difference. So the work done in bringing a unit charge from a fixed point or initial point, another fixed point. Let's say final point. So that is called the work, that is called the potential difference. What was the idea of electric potential? What was the idea of electric potential? Do you guys remember? What was the idea of electric potential?
So
The
the
idea
idea
of
of
electric
electric
potential was,
potential.
yeah,
Yes, so the idea of electric potential, like,
yeah. What
so I
was
mean,
electric
isn't
potential?
electric potential was just like the energy that was needed, right, to like move like from a
Yes,
charge of like to move a charge. I mean,
energy.
that's
We
the
have not talked
energy.
about it.
No, it's in the class we talked about, right? Not in this class, but at least in my school we talked about it.
Yeah. So we are
Yes,
not
like
providing any energy. So
no, sir, it's
we're
like
talking
the
about
amount of
the
work
work,
required, right, to
right?
like move a charge.
Yeah, yeah. So that is the amount of work, right? Not energy. We are so we are doing some work, not
Yes, sir.
the external force. So amount of work done in bringing a charge, a unit charge, from infinity to a fixed point. That was the electric potential. But potential difference is what? The work done in bringing a unit charge from a fixed point to another fixed point, right? So that is the difference between electric potential difference. In electric potential, we are taking the charge from infinity to a fixed point. The initial point is infinity, right? And potential difference is from some initial point to another initial point, right? So that is the potential difference. So how this is related? So potential difference, this is the work done in bringing a charge from initial point to final point, and unit charge we are taking. So from here we get this right. So this is Q final final. So that is how we relate this work done with the potential. Now let us find out the potential difference. So what would be the potential difference? And I will note it down, right. So potential difference in electric, right? So this would be how much? We know that work done is Q final, V final minus V initial, and we also know that work done in the presence of electric field is Q and minus E dot R final minus R. Right, this we also, and this we are doing for, let's say, uniform electric, right? So this we are doing uniform electric field. So then what would be if we compare these two things, right? So left hand side is equal. So RHS would also be equal. So this would be minus QE and dot R final minus R. So QQ will cancel and potential difference would be how much? That would be minus dot R minus minus R with this electric field. And if we have a variable electric field, then potential difference would be how much? This would be simply minus E dot dr and R initial and R final. So this would be the potential difference, right? And if I take my initial point to be infinity. So if I take my initial point to be infinity, then my potential difference becomes electric potential when my initial or not, but when the initial point is infinity. Right. So V final minus V initial, right? V initial is V at infinity. So then this would be minus infinity to some R, and this is E dot dr. So we know that at infinity, potential becomes 0. So V at infinity is 0. So then we will get this thing as the electric potential. This would be minus infinity to R E dot dr, right? So this would be the electric potential in the presence of electric field. So that is the idea of electric potential in the presence of electric field. Okay, so you guys please note it down, and if you guys have any question, please tell me. Please tell me if you guys have a question. Otherwise, please note this down. Yeah, please note it down. Yeah, whenever you guys want me to scroll down, please tell. So up
Yes, sir.
until now, what are the parameters that we have talked about? We have talked about work done, we have talked about potential, there are only three parameters that we have talked. Work done, potential, potential difference. These are the three things we have done. Yeah, whenever you guys want me to scroll down, please tell.
Yes, sir. I'm done. You can scroll down.
Guys have put it down. Yes.
It's okay, sir. Done.
Yeah. Okay, so this was the difference between the electric potential and potential difference, right? So now let us understand about this very important relation and that is the electric potential, right, or the electric field as the gradient. This is a very important topic. Electric field as the gradient of potential. Right. So we saw what? We saw that the potential difference was what? So this V delta V was minus of E dot dr. Right. So if we take integration sign, right, and if we take this in the opposite side, so this will become right, and this is delta R, right? So this is d. So if I take this integration sign in the left hand side, so this will become differentiation. So this will become dv by dr, right? And I should write delta, and this is minus. Right, so this is how we write the electric field as a gradient of potential. So this we can write as minus dv by dr. Right. This is what is minus e dot delta r. Right. Similarly, we know that what is the work done. This is q and delta v. Right. Delta V is V final minus V initial. So if we compare these two things, so what would be our electric field? That would become so this would become right if we ignore the vector part. This would be minus of yes, there's this Q in there, right? So this Q will cancel. And this would be minus delta V by delta R, right? So this is how we get this relation. This negative sign represents. So this negative sign represents that direction of electric field, here potential lower potential. Have a potential of 10 volt in there, and if you have a potential of 5 volt, right? So what would be the direction of the electric field? Right to left or left?
So left. So left to
Direction
right.
left to right
Higher.
is lower to higher. Left to right is
Oh, no, sir. I mean, like from left to right. I mean, from 10V to 5V, sir. So
that
right
is
to left,
right
right?
to left, right? Right.
Right to left.
So okay, so this is okay. Yeah, what am I saying? Right to left? Yeah, looking at right or left. So if we are going right or we are going left, I should say right. Yeah, We are going right. 10 to 5, right? So that would be the direction of the electron. So that is what this negative sign has. So let's say that if you have a electric field which is minus 3 volt, if you have an electric field which is minus of 9 volt, so what would be the direction of the electric field, right or left? Yes, what
So
would be the
from minus
direction?
3V to minus 9V.
Yeah, so this would be the direction of it. Yes, absolutely. So this is a very important relation, right? This is a very important relation and it comes very handy. So in these type of question, what they will give? So they will give, right? They will give that question would be that the potential in a region is very like varying as follows, right? E is x square, let's say y z square, and let me write it as minus. So this is your type of potential which is given, right? And then find the electric field at let's say find the electric field at the point A, which is one. Find the electric field. Okay, is this question clear? So what do we know? We know
So
that
that V is
how
equal to,
yeah.
yes, sir, V is equal to
So
minus
how the
4x square.
electric field is related? Yeah. So E is minus dV by dr, right? And this is a partial differentiation, right? Not the complete differentiation. So this is a partial differentiation. You guys have done this partial differentiation, right? So then we can calculate this is dr. So if I want to calculate the x component, so x component would be simply minus dv by dx, right? Y component would be minus dv by dy. Then it would be how much? This is minus dv by dz. So these are the different components. So what would be the electric field vector, guys? What would be the electric field? I have x component, y component, z component. So electric field would be ex I hat, ey j hat, ez k hat. Here, is this thing clear,
Yes, sir.
guys? The electric field at 1, 2, 3. Y is 2, Z is 3. This is given, right? We'll come to this point later, but let us calculate the EX, EY, EZ first. So we know that E is minus 4 x square y z square, right? This is my potential. So first let us calculate EX. EX is minus dv by dx. So I will keep x as variable, all the other things are constants. So minus of minus 4x square yz square. So what is the variable in here? In this minus 4x square yz square, if I'm taking the partial differentiation in terms of x, so what is the variable in here? What is the variable? So do you guys remember this differentiation? We have done this differentiation part. Yes.
The
Yeah. So
variable
x
is.
is variable. X is variable. All the rest are constants because I'm taking the partial differentiation. I can do this in only partial differentiation. If I take this thing, then all the other things are variable. But if I do partial differentiation, then my only x is variable. All the rest I can treat them as constant. So yz square 4 minus all these positives, so 4yz square is a constant. D by dx of x square. How much is this thing? Differentiation, you guys said no. This is x to the power 2. So 2 will come down and in power you will subtract 1. This would be how much? This would be 8xyz square. Right? Is this clear?
Yes. Wait.
Similarly,
So you're
y
lagging a lot,
is
sir, for me.
right. So minus 4x. Oh, I'm lagging. Why am I lagging?
No, sir.
Why?
It's like you're getting slowed down when you're talking. It's becoming very slowed
Oh,
down. It's okay now, but I don't know why. For some reason, in the middle, sometimes out of nowhere, you just start lagging for some reason.
yeah, yeah. Sometimes, yeah. So internet is maybe it is fluctuating. That's why. Yeah. Now it may be lag, right?
Yes, it's okay.
Okay. So now let us. So again, this is y, right? So what is the variable in this thing? What is the variable?
Sir,
Y is the
X.
variable.
Well, yes, sir.
You
Why
are
is the
taking the
variable
difference.
is because it's from below. Yes, sir. Sir, you're stuck again. Sir.
Square z square outside now. Yes. Hello. Happening.
No,
Yeah.
yes, sir. You got stuck again, sir.
I got stuck again. Why did it happen? Why? Maybe.
So maybe it's my end. I'm not completely sure if Mir is experiencing the
Yeah,
same,
Mir
sir.
can. Yeah, Mir can confirm this, right? But Mir usually doesn't respond. Yes, EMT. Yeah, we can talk to us. Okay, so dy that is 1. So this would be 4x square z square. So we have got ey. Now we need to calculate ez. So again, this is dz. So minus minus d by dz of minus 4x square y square z square. Now z square is the variable, so all the other things we can take it outside. So d by dz of z square. So that would be how much? That would be 2z. So this is 8x square yz. So we have got all the components. Now we have to write a vector. So vector is exi, dy, j and ez. So this is what was the ex component? 8xyz square. 8 8xyz square I hat plus 4x square z square j hat plus 8x square yz k hat. So this is the electric field. Now we have to find out the electric field at 1, 3, right? Like this was the value of the x, y, z. Yeah. So x we have to put 1, y we have to put 2, z we have to put similarly x is 1, z is x is 1, y is 2, z is, this is how much? 9, 9, 2, and this is 16. So 16 into 9 is how much? 144. I had, this is 9 fours are 36. J had, this is 6 and 48. So this would be the electric field at that. So this is how we use potential to find out electric. So this is very important, right? And this has been asked in many exams. Uh, okay, you guys, please note it down. So, and if you guys have any questions, please ask. Right? Please tell me if you guys have any questions. So this part you have noted. down. Yes, very. Yeah, whenever you guys, guys want to scroll down.
Yes, sir. Scroll down.
Yes,
Yes, sir, I'm done. Sir.
done. Okay, then we will-
Yes, sir, done.
done. Yeah.
Yes, sir, done.
Done. Okay, so now,
Yes, sir, 1 minute. I'll just come from the washroom, sir. I'll just quickly come in 1 minute, sir.
okay, yeah, so
Hmm.
then the time would be over. Yeah,
No, sir, it's fine, sir. I just need to pee, sir.
okay, yeah. Then let me check what, yeah, what we have done, what we have done, what we have done. Then you just come from the next topic. Yes, me, are you there?
Yes, sir.
Yes. So, do you have any doubts? You are silent. Whenever you have any doubt, please don't hesitate. Okay. Yeah. So, do you have any doubt in what are the three things that we have learned so far? We have learned how to calculate work done in external force, right? How to calculate electric potential, and how to calculate the potential difference. So these three things we have done, and we also got to know about the electric field as a gradient of potential. These four things we have done, right? Now we will talk about potential. That's great. But if you have any doubt in these, please tell.
Yes, sir, I'm back.
Yeah, you are back. Yeah. Okay, so now we will talk about this potential energy, right? So we have charges Q1 and Q, and we know that how this how this work done is related with the potential, right? So we know that if we have a potential P, right, and then we have a charge Q, so work done would be simply Q, right? And but if we are taking, so this is the electric potential. But if we write it in the form of potential difference, so that would be VB minus, right? If we are taking from infinity to fixed point, so that is simply QV, right? And if we are taking from A to B point, so that is this. So recalling this thing, right? Recalling this thing, let us understand about what is the potential. So it arises due to conservative interaction between charges, right? And how is it defined? So it is the work done in bringing charges from infinity different fixed points, right? So this is, and also it is defined as the work done to make a system. Okay, so the time is you had this exam, so we'll stop it here. We'll continue from there, right. No need to note it down. From the next class, when I will define these things again, so then I'll give some time. Okay,
Yes,
we'll
sir.
stop it here, and yeah, see you guys tomorrow, right? In the wave of this. class. So
Allah
Allah Hafiz,
Hafiz.
guys. Allah Hafiz. But you guys
Allah
have this
Hafiz.
class assessment. So when this class
Okay,
is
sir. I'll do that first and then I'll go for the class.
okay, yeah. Okay, bye
Okay,
guys.
sir.